in terms of exponential functions, you may have heard of the term asymptote. What is that even? The asymptote. The asymptote is a line that the graph approaches but never reaches. I'll write that down. So for example, we have our exponential function that is going to be y equals 2 to the power of x. Y equals 0 is the asymptote here. And it's usually drawn like this with a dotted line. Because y equals 2 to the power of x exponentially approaches it, but will never touch or cross this line. We can take a look at a table of values to see why that is the case. It's interesting to analyze why things in math make sense. So I'm going to just draw this table of values for x and y. What you can do is just plug in some values. I'm going to write them out, and since we are looking at the negative x's, that's where the asymptote is, that's why I'm adding in a little bit more on that side. And then you just plug it into here and you get the output. In this direction, with positive x's, it will just get larger and larger as the numbers increase to infinity, as you can see with this kind of graph. But here, you can see that the numbers are getting smaller and smaller. You can even try to plug in some kind of very big negative value, negative 100. And what you're going to get is something like this. They are approaching 0, but you will actually never get 0. There isn't a value to plug into y equals 2 to the power x to get y equals to 0. You can't do that. There is no value. It becomes super small, but never actually 0. And that is why it's an asymptote, because we will never cross this line. In fact, when it's drawn, it's more just for ourselves to understand the function. The function itself will just keep going, and you can try to graph it and then zoom in more and more and more, and you can see how maybe even your calculator will show this as 0 because it's so close, but it will never actually be 0.